The last concept from section 1-1 is average rate of change. And so average rate of change is the ratio f of b minus f of a all over b minus a from a graph. So if I look at what's happening here, f of b minus f of a is this distance, this vertical distance between my 2 points. Okay, so between point A and point B, the vertical distance is f of b minus f of a. If you think about it as what you've learned from the slope formula of a line, that's like our y2 minus y1 portion from the slope formula. And then the horizontal distance between A and B is the denominator. And so that, if you think of your slope formula of a line, is x2 minus x1. So remember, average rate of change is referring to a function that's nonlinear. And so the average rate of change is the same as the slope of the line segment between the points. So if this were a perfectly straight line, that would be its slope. So that's why I'm comparing it to the slope formula. So what we're going to look at here is using a graph. What is the average rate of change on 3 different intervals? So they're first giving us from -2 to 0. Okay. So if I think about that in terms of the formula, I have to figure out f of 0, subtract f of -2, and then divide that by 0 minus -2. Okay. And so what I want to do is, these are x values. So they're giving me the x values a and b. So 0 is my b. And notice that it's always an increasing value. That's true for all of these. So if A is always going to be smaller than B. The number on the left, since it's an interval, is always smaller than the number on the right, because that's the foundation of intervals. So I've identified the points on the graph. What I'm using those points for is to find f of A and f of B. And so we know that those values are equal to the y-coordinates at those points. I'm going to simplify the denominator. So 0 minus -2 is going to be 0 plus 2. And so what we want to find first is f of 0. So at our point B, the y-coordinate, right, this point is 0, 0. So the first 0 represents our x. We want our y, so we're going to plug a 0 in for that value. For point A, it's -2, -4. So that means that f of A is -4. So our numerator is going to be 0 minus -4. And so notice that that's going to give us 0 plus 4. So this turns into 4 over 2, which is equal to 2. What we should notice is that, remember, we talked about that vertical distance here. So this one you have to be careful because the interval's not the same on the x and y axis. So our x-axis is going by 1/2 and our y-axis is going by 1. But if we look at the numbers, to go from here to here, the vertical distance is 4. And then to go from there to that point to point B, the horizontal distance goes from -2 to 0, so that's also 2. Okay, and so that's, again, where those numbers are coming from visually. Let's just look at one more. So let's look at the 0, 1. So if I identify 0, 1, 0 is going to be my A, and then 1 is going to be my B. So let's find the point at 1. The point at 1 is 1, -4. So if we're identifying this average rate of change, we're looking for f of 1 minus f of 0 over 1 minus 0. So if we plug in our values, f of 1 we said was -4, and then we're going to subtract f of 0, which is the point 0, 0, so that's also 0, over, I'm just going to simplify, 1 minus 0 is 1. So what we've got then is we have -4 over 1. So our average rate of change here is -4 between those 2 points. Okay, so for average rate of change, remember that using our formula and connecting it to the idea of the slope formula, if that's easier for you, y2 minus y1 over x2 minus x1, or looking at it visually, but making sure to take note of the intervals in your axis for your x and y values. So the vertical distance for this one was -4. So notice to go from the point on the left to the point on the right, we're going down 4. And then we're going right 1. And so we could also avoid the formula and look at it visually because we're given a graph.